I'm Anil Kumar. In few videos, I'll cover important trigonometric identities which will help you to review this unit for your test. So I have a list here which is kind of like this. So you can actually pause the video, copy these identities. We'll take them one by one. Okay. We'll begin with the very first one, which is written here, and then move on. Some of these identities will involve compound angle and double angle formulas. Here's the very first one, which is prove 1 plus tan square x over tan square x equals to cosecant square x. So it's kind of a review for us. So what I will do here is we'll start with the very basic trigonometric Pythagorean identities. For example, you all remember cos square x plus sine square x is equal to 1. So that is the basic Pythagorean identity which we all know. Now in this particular identity, if I divide everything by cos, what do I get? Cos square x plus sine square x equals to 1. If I divide everything by cos square x, let us say, what do I get? I get 1 plus sine over cos is tan. We get tan square x is equals to secant square x. So that becomes the second trigonometric identity, relating Pythagorean form of an equation, right? If I divide by sine square x, then what happens? Let me do that also. Cos square x plus sine square x divided by sine square x, 1 over sine square x, right? So here cos over sine is cot. We get cot square x plus 1 equals to cosecant square x, correct? So this is just a reminder and an approach to get the other two Pythagorean trig identities from the one which you are so familiar with, right? So I find sometimes students not remembering these. Now as you can see here, 1 plus tan square x is secant square x. So we could apply this identity and solve. So one of our methods to solve this could be, let's call it method 1. 1 plus tan square x. So what we will do here is that we'll start from the left side and say 1 plus tan square x is secant square x. We are using this. So I could write 1 plus tan square x over tan square x as equals to secant square x over tan square x, correct? Now we could write them in terms of sine and cosine. So we can do secant is 1 over cos square x, and tan is in the denominator, so we'll write sine square x over cos square x. Now from here clearly you can see that cos square x cancels. So we have 1 over sine square x, which is cosecant square x, or which is right side. Is it okay? So that becomes one proof or one method to solve it. And with identities you'll find many methods, right? Let's see what is method number 2. Now let us say you don't remember this, then what can you do? Then what we can do is we can again start with the left side. Why do we start with the left side? It's more complicated and can be simplified. That's the whole idea. So we have 1 plus tan square x divided by tan square x. We could write this as 1 over tan square x plus tan square x over tan square x, correct? Now that gives us 1 over tan. Let me write this in sine and cosine, just as we did earlier, right? So start with denominator, sine square x over cos square x and plus tan square x plus over tan square x is just 1, correct? So, or we could have straight away written cot square x also, right? Okay, we could have straight away written 1 over tan is cot. So prefer to write cot square x plus 1, right? So either way, you could either go from here to this stage or straight here. This is preferred, correct? Now, you know what cot square x plus 1 is? Cot square x plus 1 is cosecant square x. So you can write this as cosecant square x, which is same as the right side. And you can prove it. So either way, it works. So I hope that helps. So remember one thing, that there is no hard and fast rule. You might take a step extra sometimes or lesser, depending on which method you adopt. However, if you start from one side, you're going to end to the other side for any trigonometric identity. So my suggestion is that even if you take few steps more than the best solution, it is okay. Remember these identities as we move along. I hope that helps. Now take up the next video where we will take an example with a compound angle A plus B. Now let's prove the identity sine pi by 4 plus x minus sine pi by 4 minus x equals to square root 2 sine x. We'll apply the formula sine A plus B, which is equal to sine A cos B plus cos A sine B, and we know what is sine A minus B. A minus B is sine A cos B minus cos A sine B, correct? Now, if you do take away, that is to say, if you do sine A plus B minus sine A minus B, what do you get? These two terms cancel off and you get 2 of cos A sine B, right? That is to say, if I want to find what is sine A plus B minus sine A minus B, that should be equal to, this is 0, and that makes it 2 cos A sine B, right? Now in our case, A is pi by 4 and B is x. And therefore, we can now rewrite the question as sine pi by 4 plus x minus sine pi by 4 minus x, which is the left side, as equal to 2 times cos of pi by 4 times sine of x. Now, if you look into pi by 4 right triangle, as you know, these sides are equal for pi by 4. We know 2 times cos pi by 4 is 1 over square root 2 sine x. Now that could be simplified as square root 2 sine x, which is the right side. You see that? So that is how you could prove the given identity. I hope that helps. So here is a trigonometric identity which involves double angles. We need to prove 1 minus cos 2x divided by tan x equals to sine 2x. So first let's recall these formulas. We had, let me write down here. If I have cos A plus B, we could write this as cos A cos B minus sine A sine B, correct? So if I make 1 minus cos A plus B, a equal to b, then what happens? Then in that case, I could write this as cos a plus a, right? Replacing b with a. And I get cos a minus sin a, which is nothing but cos square a minus sin square a. So that is one of the double angle formulas for cosine. Is that okay? So you could write this as cos 2a, which is a plus a, equal to all this, which is cos square a minus sin square a. Now this formula could be written in many other ways, since we know that cos square a is 1 minus sin square a, correct? And we could also write sin square a as 1 minus cos square a, right? We could also write sin square a as 1 minus cos square a. So if you substitute 1 minus sin square a, you could get 1 minus 2 sin square a formula for cos 2a. And you can also write cos 2a as 2 cos square a minus 1. Perfect. So I've taken all this space to show that. Now when we are trying to do sine 2x, let me use this space for sine 2x. So we have sine a plus b as sine a cos b plus cos a sine b, and sine 2a, when I make a equals to b, this becomes sin a cos a plus cos a sin a, correct? And that gives you 2 sin a cos a. So this is the double angle formula for sine. So we'll use these two formulas basically and then solve. So for sine 2a, there is no problem, just one formula to use. For cos, you can use any one of these. Preferred is this one, correct? In our case, we have 1 minus cos 2a. It's a good idea to use the one which has 1 as positive. So in this particular case, I'll prefer to use this formula, right? So we'll use this formula. You'll see why, because it is 1 minus cos 2a. Now let's see how easy it is to solve this. We'll begin with the left side, since it can be simplified, which is written as 1 minus cos 2a divided by tan x. Now cos 2a is being replaced by 1 minus 2 sin square a, correct? Divided by tan x. Let me write this as sin x over cosine x. Now if you open this bracket, 1 minus 1 is 0, minus minus becomes positive, so we get 2 sine square, well, I made it a, it is x, correct, sine square x over sine x over cos x, correct? So let me rewrite this. 2 sine square x times, sine is in the denominator, cos comes in the numerator, right? So we have sine x over cos x. This is a good way of writing. So straight away, what you see here is that sine x will get cancelled. So what you get here is 2 sine x cos x. And what is that equal to? 2 sine x cos x is sine 2x. Perfect? Which is the right side. So we have proved that left side is equals to right side. So I hope this is straightforward for you, right? Now we'll take another example where we'll need to factor. Okay. Now let's prove the trigonometric identity. 2 cos x minus 2 cos cube x equals to sin x sin 2x. So let's begin from the left side first. So which is 2 cos x minus 2 cos cube x. We could actually factor 2 cos x and then write this as 1 minus cos square x That gives us 2 cos x. 1 minus cos square x is sine square x. Now we could rearrange it, right? So, well, I'll take more steps just to show you what I'm trying to do. I'm writing sine square x as sine x. And then I'm rewriting this as sine x. I'm writing 1 sine x because I have to prove that on the left side of this expression, and writing these together as 2 sine x cos x. Now that part is sine 2x. So I could write this as sine x times sine 2x, which is the right side. Is it okay? So that is how, using factoring, you could actually prove this identity. I hope that helps. Now we'll take up a trigonometric identity which involves double angles. We need to prove sine 2t divided by sine t minus cos 2t divided by cos t is equal to secant t. So the formulas which we are going to use is sine 2t will be equals to 2 sine t cos t, and cos 2t could be written as cos square, I wrote cos 2a, so let me write down cos square a minus sine square a, correct? You know there are different forms. It could be used in 3 different forms. I'll use this one, correct? So let's begin from the left side. Sine 2t is 2 sine t cos t over sine t minus cos 2t, I'm writing this as cos square t minus sine square t divided by cos t. Now sine t cancels. So we have 2 cos t here minus, let me rewrite this as cos square t over cos t. Okay, or no need, we'll just keep it like this, minus sine square t over cos t. Now we'll take a common denominator, right? So if I take a common denominator as cos t, I get 2 times cos square t here minus cos square t, and that becomes plus sine square t, correct? Now at this stage, 2 cos square t minus cos square t will result into cos square t, and then we have plus sine square t divided by cos t. Now cos square t plus sine square t is 1, so we get 1 over cos t. And 1 over cos t is secant, so we get secant t, which is the right side. Is it okay? So like this, in small steps, you can actually prove this identity. I hope that helps. And here is one of the most important questions on trigonometric identities involving cofunction identities. The question here is to prove cosecant pi by 2 plus x divided by cosecant 2 pi minus x plus sine pi minus x divided by sine 3 pi by 2 minus x equals to 2 cotangent 3 pi by 2 plus x. Now to prove this identity, I like to draw your attention to what we have learned so far relating cofunction identities. I actually remember it using 2 important aspects. The first one is the rule itself, in which quadrant which ratio is positive. So in quadrant 1 all are positive, in quadrant 2 sine is positive, here tan and then cosine. So you remember this, all students take calculus or any other way. So first part is to understand where each one of them will be, and then we'll figure out what cofunction identity will it be. That is one part. Second thing which we need to understand is that if we are talking about, let us say, situation where it is pi by 2 plus x, then in that case, we are talking about two triangles. Let us say first triangle, we say this is with the angle x. The other one is kind of pi by 2 plus x means that it will be like this. Do you see that? So in this case, the angle which we are talking about is this angle, which is pi by 2 plus x. What do you notice here? You notice that the base, let's say this is base, and that is opposite side. So what really happens is that this opposite side becomes equal to the base. Do you see that? And the base becomes the opposite side when we are talking about pi by 2 plus x. So in that situation, what happens is that cos becomes sin x, or vice versa. Tan x becomes cotangent x, or vice versa. Do you get my point, right? Of course, we have to combine these two informations. That is to say, when is each positive or negative. So we could have some positive negative terms here. So we'll figure out positive negative from the rule in which coordinate what is positive, and this kind of thing, if it is pi by 2 or something, opposite side becomes the base becomes opposite, resulting into that transformation. You get the idea. However, if we have a triangle which is kind of like this, same situation with an angle x, and if I do a transformation where this is kind of reflected here or there, whatever, these sides remain opposite sides. Do you see that? All are opposite. So basically, in these situations which involve pi or 2 pi, sine remains sine, right? So sine x will be sine x, cos x will be cos x, and tan x will be tan x, right? The ratio doesn't change. You get an idea, right? With this in mind, I'm going to prove this identity, right? So you don't really have to remember many things, but the concept which I've shown you here is one of the most important. So let's begin with the left side. So left side. First expression here is cosecant pi by 2 plus x. So cosecant will change to secant. So let me write down this as secant x. You get an idea, secant x. Now we'll check the sign. When I say cosecant, it means 1 over sine, so it relates with this. Pi by 2 plus x, we are in quadrant 2, where it is positive. So therefore, it will remain positive, because the output of cosecant, which is 1 over sine, will be positive, divided by cosecant 2 pi minus x. Since it involves 2 pi, cosecant remains as cosecant. Sine 2 pi by 2 pi minus x means you are in this quadrant. Sine is negative here, so this becomes negative. You get an idea, right? Let's do it once again for the next expression. Sine pi minus x. Whenever pi is involved, sine remains sine. So it will be sine x. Pi minus x means you are again in quadrant 2. Sine is positive, so this is positive. I need not write positive. Sine 3 pi by 2 minus x. 3 pi by 2 means somewhere there, kind of like this. Do you see that? Okay, minus means of course it will be on this side. Okay, but sine becomes cos. So we'll write this as cos x. Since you are in quadrant 3, sine is negative, I'll write negative here. Does make sense to you? So go through this part clearly and see if you've understood, and then move on. So we have this kind of an expression. Now let's rewrite. Secant is 1 over cos, so I'll write this as secant is 1 over cos. Let me write this as 1 over cos x, and cosecant is 1 over sine, so I'll write 1 over sine x. And I could write this negative first here. Is it okay? Now here again we have negative sine x over cos x. Now that's what we get here also, sine x over cos x, right? So we have negative sine x over cos x, negative sine x over cos x, which is negative 2 sine x over cos x. Do you see that? So that becomes our left hand side. Now let's look into the right hand side. Okay, so on the right side we have 2 cot 3 pi by 2 plus x. 3 pi by 2 plus x means you are in quadrant 4, so this has to be positive. Cot is sine over tan is negative, this has to be negative. So I'll write this as 2 here. And since it is 3 pi by 2 plus something, cot changes to tan, so it becomes minus 2 tan x. And that's what we have here, which is minus 2 tan x. Do you see that? So minus 2 tan x is same as this, which is right side. So we have shown that left side is equals to right side. So that is how you should be doing a cofunction identity. It took me longer just because I was trying to explain you this concept, but otherwise kind of straightforward, but important to understand. I hope you understand and appreciate it. Feel free to write your comments on this set of videos. If you share and subscribe, that'll be even better. Thanks for watching.